So good morning everyone, my name is Georgialyn Isbisada and I'm going to discuss the topic about color image processing and digital image. So the use of color in image processing is motivated by two principal factors. First, color is a powerful descriptor that often simplifies object identification and extraction from a scene. Color image processing is divided into two major areas. First one is full color and pseudo color processing. In the first category, the image in question typically are acquired with a full color sensor, such as a color TV camera or color scanner. And the second category, the problem is on of assigning a color to a particular monochrome intensity or range of intensities. Until recently, most digital color image processing was done at the pseudo color level. However, in the past decade, color sensors and hardware for processing color image have become available at reasonable prices. The result is that full color image processing techniques are now used in a broad range of applications, including publishing, visualizations, and the internet. So, color models, the purpose of color models, it also called color space or color system, is to facilitate the specification of colors in some standard, generally accepted way. In essence, a color model is a specification of a coordinate system and a subspace within that system where each color model is a specification of a coordinate system and a space within that system where each color is represented by a single point. The type of color models. The first one is the RGBG color model. And the RGB model, each color appears in its primary spectral components of red, green, and blue. This model is based on a Cartesian coordinate system. The second is the CMY and AMYK color models, as indicate cyan, magenta, and yellow are the secondary colors of light. Alternatively, the primary colors of pigments. For example, when surface coated with cyan pigment is illuminated with white light, no red light is reflected from the surface. That is, cyan subtracts red lights from reflected white light, which itself is composed of equal amount of red, green, and blue light. The third is his color model. The model are about to present called the HSI, hue, saturation, and intensity color model decouples the intensity components from the color carrying information, hue and saturation in a color image. And image processing and color transformation, there is also what types. The first one is pseudo color image processing. Pseudo color, also called as false color. It's the image processing consists of assigning colors to gray values based on a specified criterion. The term pseudo or false color is used to differentiate the color of assigning colors to monochrome image from the process associated with true colors for human visualization and interpretation of grayscale events and an image or sequence of image. Gray level to color transformation is the second. This transformation is more general and thus is capable of achieving a wider range of pseudo color enhancement result than the simple slicing technique discussed in the preceding section. Third is the basic of full color image processing. In this section, we being study of processing techniques applicable to full color image, although they are from being exhaustive. The techniques developed and the section follow are illustrative of how full color images are handled for a variety of image processing tasks. The fourth is color transformation. Color transformation deal with processing the components of a color image within context of a single color model. Color complements and slicing. Our interest in complements stems from the fact that they are analogous to the grayscale negatives. As in the grayscale case, color components are useful for enhancing detail that is embedded in dark regions of a color image, particularly when the regions are dominant in size. Color slicing. In color slicing, it highlighting a specific range of color, and an image is useful for separating objects from their surroundings. Color slicing is either to display the colors of interest so that they stand out from the background, or it uses the region defined by the colors as a mask for further processing. The most straightforward approach is to extend the grid level slicing techniques. Tone and the corrections. Color transformations can be performed on most desktop computers. In conjunction with digital cameras, flatbed scanners, and inkjet printers, they turn a personal computer into a digital darkroom, allowing tonal adjustment and color corrections. The maintenance of high-end color reproduction system to be performed without the need of traditionally outfitted wet processing facilities. Conclusion of this topic is this study in this is an introduction to color image processing and covers topics selected to give the reader a solid background and the techniques it used in this branch of image processing. A treatment of color fundamentals and color models was prepared as foundation materials for a field that is in its own right wide in technical scope and areas of application. In particular, we focus on color models that we felt are not only useful in digital image processing but would also provide the tool necessary for further study in this area of color image processing. And that's all. Thank you.